Good day everyone, this is Chemical Engineering Plant Design Final Defense, dated today. We are the Grammars. My name is Karen Claire Daguman and my teammates are Bunhan, Gran, Inez, Umboy, and Ursos on the production of sodium alginate and hydroxypropyl cellulose-based hydrogels together with our plant design advisor, Engineer Arnold Duguban. This chapter only discusses the major equipment utilized in the production. The equipment design details were also added in a table form. Highlighted in the equipment design chapter are the mixers M1 down to M6, the decanter centrifuge and the alkaline extraction, the centrifuge and the dryers and the acid pretreatment and the production of sodium alginate. In the acid pretreatment, with the nature of the acid being corrosive and will attack the vessel resulting in a spill, 3 PVC mixing tanks with an agitator blending vessels are used. The volume of the vessel is 5 cubic meters and is jacketed for maintaining the temperature in the reactor. The unit cost is 184,510 pesos. It is equipped with automatic or program PID, having a temperature sensor, gauge, and level gauge. For the alkaline extraction, 6 jacketed stainless steel mixing tanks are required. The vessel volume is 5 cubic meters and ought to maintain the temperature by a double layer with cooling water and or electric steam heating. The unit cost is 100,339 pesos with a temperature, level, and flow control and display. Only 1 chemical dosing mixing tank with agitator is required for bleaching the sodium alginate. As such, an HDPE or LDPE vertical cone bottom chemical tank with specific gravity of 1.9 is recommended. The vessel volume is 5 cubic meters and is operated at a room temperature. The unit cost is 9,489 pesos, having a uniform wall thickness and externally and internally smooth and leakage-free. For the acid addition, 6 PVC mixing tanks with agitator blended vessel are used. The vessel volume is 5 cubic meters and the temperature must be regulated to 40 to 50 degrees Celsius by having a jacket or coiler pipe for cooling or heating, temperature sensor and gauge, and level flow gauge. The unit cost is 184,510 pesos. For the sodium carbonate and alcohol addition, 6 LLDPE chemical dosing mixing tanks with agitator are utilized. Inside a 5 cubic meter vessel volume, the temperature of the tank is maintained at a room temperature. The unit cost is 20,032 pesos, having an intensive vibration resistant and optimum performance as the sanitation. Lastly, in the formation of SAHPC adsorbent beads, 4 jacketed stainless steel mixing and extrusion tanks with 5 cubic meters vessel volume are used. The reaction is just operated in a room temperature by having a temperature, mixing speed, level, and flow display and control. The unit cost is 100,339 pesos. In the alkaline extraction, a decanter centrifuge is used which functions to separate and decanting the sodium alginate from a liquid material. The operation is continuous and the materials are shown in a specification sheet. With its design of construction as a stainless steel, the maximum throughput has a value of 12,000 kilograms per hour. It has a pressure of 101.325 kilopascals at 80 degrees Celsius, a diameter of 5 meters, a height of 3 meters. It has a motor power of 30 kilowatts and a heating power of 392 kilowatts with an agitator speed of 2 to 45 revolutions per minute. The unit cost is 1,044,531 pesos. This is suitable for solid phase dewatering, suitable for liquid phase clarification and separation, suitable for liquid-liquid solid 3-phase separation, and suitable for size grading of various suspensions with solid phase particle size of 0.005 to 15 millimeters. The centrifuge in the production of sodium alginate functions as a separation of the sodium alginate from a liquid material. It has a design data of 120 cubic meters of its vessel volume, also at 101.325 kilopascals, with a temperature of 28 degrees Celsius, a diameter of 0.8 meters, a height of 4 meters, motor power of 150 kilowatts, heating power of 263 kilowatts, and an agitator speeds of also 2 to 45 revolutions per minute. The purchase cost of this equipment is 882,235 pesos. This recovers about 90% of oil relating to demulsification effect, temperature, and others. The solid content of the liquid phase after separation can reach less than 5 or equal to 8%, and also as the dryness of the slag phase after separation can reach to 40 to 60%. Another centrifuge in the production of sodium alginate with the same functions, but this differs to its materials handled in its design data. This stainless steel centrifuge has a diameter of 0.8 meters, a height of 4 meters, a motor power of 150 kilowatts, a heating power of 39.92 kilowatts, and with the same agitator speed. In the design of this plant, a rotary dryer was also utilized to remove moisture. It is the machinery used to lower the moisture content of calcium alginate by exposing it to hot gas. This dryer is used in drying the calcium alginate from liquid material and is rotary and continuous. Its design data has a 127 cubic meters of its volume at temperature 50 degrees Celsius. It has a 2.6 in diameter at 2.4 meters long. It has a motor power of 75 kilowatts, a heating power of 39 kilowatts, and an agitator speed of 1.5 to 5 revolutions per minute. This amounted to 812,827 pesos of its purchase cost. This has a high heat efficiency which can reach 70 to 80% and has a wide applicability and elasticity. Its drying period of materials is normally 10 to 300 seconds, so it is suitable for heat-sensitive materials. It also can be pressure-reducing operated if it is put in a vacuum vessel. Another rotary dryer in the production of sodium alginate, which is also continuous in a rotary equipment with the materials handled, sodium alginate, water, ethanol, and sodium chloride is used. This operates the same with the previous dryer but only differs in its heating power that has a value of 87 kilowatts. This also has a drying period of materials normally 10 to 300 seconds, so it is suitable for heat-sensitive materials. It also can be pressure-reducing operated if it is put in a vacuum vessel. For the economics, the outline is shown in the slide which discusses the cost estimation and profitability analysis of the proposed sodium alginate and SAHPC hydrogel beads production plant. The cost of the raw materials and the selling price of the product were chosen as average values of the ranges found in the industry. Based on the objectives and the material balance, the product information is tabulated below according to its features, daily and annual production, and the unit price of the sodium alginate and SAHPC hydrogel beads. In the equipment cost, only the major equipment and the plant design is accounted as shown in the slide. For the annual raw material costs and products values, the raw materials cost purchased annually together with the products values are shown in the table. For the products, co-products, and byproducts, the total annual revenue has a value of 795 million pesos per year, and for the raw materials, the total annual cost is 472 million pesos per year. For the operating labor, the annual costs are shown along with the annual operating labor cost amounted of 6,750,000 with 3 shifts per day of an operating rate of 500 pesos per shift. For the utilities, the electricity and water are taken into account, with an annual utility cost of the electricity of 48 million pesos per year and with the water of 3 million pesos per year. This total to a utility cost of 51.835 million pesos per year. In the depreciation, the monetary value of the equipment decreases over time due to use, wear, and tear. The depreciation table was based on Mark's 200% properties half-year convention and can be located in Appendix A, Table A1 of IRS Pub 946 website. It is shown that the fixed capital investment decreased over time by 2% inflation rate until such time that it reaches 50.80 million on the 20th year of its lifespan. This table shows that the total direct cost is around 59.2 million pesos and the total indirect cost is around 16.9 million pesos. This results in a fixed capital investment of 76.1 million, 11 million working capital, and a total capital investment of 87.1 million. The plant's annual total product cost at 100% capacity is shown in the table. We have a variable cost of 488.6 million pesos, 493 million manufacturing cost, giving us a 707.57 of total product cost without depreciation. As per our economic evaluation, it shows an ROI of 20.470 with a payback period of 1.387 years. This slides here shows the comments from the Defense 1. For the quality control, The agar produced from formalin soaking is analyzed by FTIR to better understand the results related to extraction procedure. AAS, or the atomic absorption spectroscopy, is used to quantify the calcium concentration released during acid pretreatment, which gives a measure of the extent of alginic acid conversion. For alkali extraction, the produced crude sodium alginate is quantified by high-performance liquid chromatography. The produced bleached sodium alginate was found using HPLC by comparing the alginate extracted to that of a commercial standard sample. The purified sodium alginate powder's whiteness was determined by a whiteness analyzer after passing through 80 mesh sieves. Additionally, color measurements were carried out. The purified alginate powder and the whiteness index WI will be determined using the Hunter LAB color measurement system. Upon linking some of the sodium alginate to hydroxypropyl cellulose and extrusion to calcium chloride, it produces an egg box structure like SAHPC beads. This has a particle size ranging from 0.2 to 0.4 centimeters. The morphology of the sample is analyzed by scanning electron microscopy, and its efficiency is known. Sodium alginate is used as an emulsifier and a gelling agent. Alginates have the best liquid gel behavior in aqueous solutions. When monovalent ions, for example sodium in sodium alginate, are exchanged for divalent ions, the process proceeds quickly, transforming the solution into a gel structure. Sodium alginate is a nearly odorless and tasteless white or light yellow powder. Organic solvents are insoluble in sodium alginate. Dissolved in water to a viscous liquid, pH of 1% aqueous solution is 6 to 8. The final product obtained was dry sodium alginate having 9.61% moisture content. After obtaining dried sodium alginate, it was blended and sieved 80 mesh. This chemical is not considered hazardous according to 2012 OSHA Hazard Communication Standard. The adsorbents SAHPC composite beads with a ratio of 75-25 has a wide and approximately round shape with a rough surface. It exhibits high adsorption ability due to porous structure, abundant functional groups, and relative low density after drying. Such cellulose-based hydrogel have a great advantages that can be used as a super adsorbent in removal of oil, heavy metals, dye, and organic pollutants from wastewater. This has a particle size ranging from 0.2 to 0.4 centimeters. The beads have the greatest adsorption capacity of 120-minute time with highest removal. For the water treatment facility, the purification of biomass starts with a collection of the streams that contains calcium alginate and alginic acid components, which are the streams 24 and 15. It will go to the settling tank where the alginic acid, calcium alginate, and calcium carbonate settle down at the bottom of the tank. All other components will be carried out to the neutralization process for the wastewater treatment. The sludge, which contains alginic acid, calcium alginate, and calcium carbonate, will undergo decanter centrifuge to separate the solid calcium carbonate from the jelly-like viscous texture of the mixture of the alginic acid and calcium alginate. The final biomass that will be produced amounted to 22 tons. In a wastewater treatment plant in a settling tank, it separates the activated sludge and clean water is applied for the final treatment of the wastewater that's ready to be disposed of in the bodies of water. Excess solids were produced since the activated sludge transforms dissolved organics to suspended solids as microorganisms. The solids will become a waste from a portion of dissolved organics, then into cells. The output waste activated sludge is then the suspension of discarded solids removed from the activated sludge system. The effluent containing sodium chloride, water, and ethanol will then undergo a reverse osmosis. This reverse osmosis process in which the feed effluent flows along the membrane surface under pressure. The purified water will then permeate the membrane and it's collected, and the concentrated water that contains dissolved and undissolved material that does not flow through the membrane is discharged to the drain. Moreover, a fractional distillation column is used to separate the ethanol and water. Compounds which are volatile will each distill at temperature well below their actual boiling points. The decanted fossil oil may be sold as a byproduct. The ethanol recovered from the crude streams is taken in as a side draw from the concentrating tower and fed back to the extractive distillation tower for repurification and recovery of its ethanol content. In the overall water treatment facility, the effluent produced is a concentrated brine solution and ethanol. The wastewater will be brought back in the streams to the neutralizing tank. This is Grammars on the production of sodium alginate and hydroxypropyl cellulose-based hydrogel. Good day, everyone.